So good morning, everyone. Today we're going to talk about the rational roots theorem. And when you read the rational roots theorem, it's really confusing. I get it because of the notation. So we're going to work through an example and try to illustrate it a little bit better. It's really not that bad. But keep in mind that the rational roots theorem is useful once you start into polynomial equation of degrees higher than 2. Because obviously, if we have a second degree polynomial equation, what tools do we have at our disposal for a second degree polynomial? We have completing the square, factoring, and quadratic formula. Those were the three big ones that we've done. Once you get to a third degree and a fourth degree, then they're a lot tougher, mostly. So the rational roots theorem is one thing that can help us figure out what the roots are. So, and this is in the book, but I just wrote it down. If you have some polynomial expression, p of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 a sub 0, then you can use the rational roots theorem. And as we all know, rational numbers can be expressed how? Fractions. Rational numbers are ones that can be expressed as a fraction. Trevor. Negative q. Oh, yeah, that's not. That, I don't know, is a stray Anagatharum mark, I guess. Thank you for asking that. Yeah, rational numbers can be expressed as fractions. So p and q are non-zero integers. Obviously, if q was 0, it'd be nasty. And p, we don't want to be 0 either. P and q can have no common factors other than 1. Every 1 is a factor of every integer. P is a factor of a sub 0, the last term, and q is a factor of a sub n, the first term. Okay, so let's do an example and try to illustrate this. If we're talking about p being a factor of a sub 0 in this example, what will p be a factor of? Which one is a sub 0? Negative 4. So p is going to be a factor of negative 4, and q is going to be a factor of 3. So then it's always a little easier when you have some real numbers to look at. So given that, what are the possible factors of p then? It's a set of numbers. What are the possible factors of 4? Okay, we could say plus and minus 1. We could say plus and minus 4. We left out 1. Plus and minus 2. Okay, yeah, that'll work. Good. What are the possible factors of q then? Don't be shy. There you go. Plus minus 1, plus and minus 3. Since 3 is a prime number, those are the only two factors. Okay, we're doing pretty well. So now we can say p divided by q. Let's see, we have 2 times 3. We should have 6. What are they? Plus and minus 1 over 1. Thank you, Heaven. Plus and minus 2 over 1. Low-hanging fruit. Thank you, Bethany. Plus and minus 2 over 3. 4 over 1. 1, 2, 3. We're missing a couple. 1 over 3. Very good. We're on a roll. Oh, shoot. I stopped doing my plus and minus. That's important. 1 over 3 plus and minus 4 over 3 plus and minus 1, 2, 3, 4, 5. We're missing 1. Aha, 4 over 1. Did we already have 4 over 1? Oh, you did. You're ahead of me. You're so fast. So fast. Okay, we're doing well. We have those. Now, and again, at this point, you're going to need to do a little bit of trial and error, but we've narrowed it down to these possibilities, and there's actually 12 if you take into account that there's a positive and a negative. So pick one. Pick one. 1 over 1. Oh, yeah, you would think, oh, sure, that'll be for sure. Well, let's find out. So we're just going to pick 1. I'll say 1. We're going to do a synthetic substitution on this. And we're going to then bring down our 3. Multiplied by 1, we get 3. Add them, we get 5. Multiplied by 1, we get 5. Add them, we get negative 4. Multiplied by 1, we get negative 4. We get negative 16. We get negative 16. We get negative 20. What does that mean? A remainder of negative 20 means what? 1 is not a root, and x minus 1 is not a factor. And that's okay. Pick another one. 2. Okay? 2 over 1. So then we can say 3, 2, negative 9, negative 12, and negative 4. Bring down our 3. 6. Add them. 8. 16. 7. 14. 2. What's next? 4, 0. Ooh, good guess, Calvin. Remainder of 0 means yes. What does it mean, Sarah? Two is a factor, a root. You threw me off. Sorry, you did that on purpose, right? 2 is a root, and x minus 2 is a factor. Okay, so that's really, really handy. Also, then we can say that x minus 2 times what equals, what did we start with? 3x to the 4th plus 2x cubed minus 9x squared minus 12x. Rats! Um, 12x minus 4 times what? Times what, Casey? Yeah, you do. X minus 2. I got my 2 from here. X minus 2 times what equals this? 3x to the 3rd plus, no, 8x squared plus 7x to the 1st plus 2 equals that. And that's pretty cool, okay? And then you could do it again to get another factor, and you do it again with this, with the original. You notice in the book they only write the coefficients 3, 2, -9, -12, and -4 one time, and then they just stack up the synthetic substitution. But that's pretty cool. You already found one of the factors, and that's pretty great. So that rational root theorem can be pretty darn handy. This might be one where I would give you a quiz next week saying no calculator. And yeah, because obviously you can graph this and see where it crosses the x-axis to get the roots. But after the electromagnetic pulse hit, we'd need some method. So that's pretty cool. Questions? Okay, I'm going to do just a little bit. How far are we into this? We're in 10 minutes. Okay, I'm going to do just a tiny bit more on this. And because I know I'm going to have people ask me for examples. And so say we had, I wanted to do one of those factoring ones where you group it. This one, x squared, x plus 2. I got to find one. Just a second. Oh, rats. This thing is still running. I thought I stopped it. Oh, well. Hey, everybody. Here we go. Let's regroup, Leah. One more quick example. X cubed plus 5x squared minus 4x minus 20 equals 0. This one's in the book, and normally I don't like doing it in the book, but let's take a peek at this. So x cubed plus 5x squared minus 4x minus 20 equals 0. I'm going to do this real fast, but the book kind of skips around a little bit. So we can group these in two parts, like right here and right here, and right here and right here. And then notice we can factor outside of these blue parentheses what common term? Yeah, x squared. So we can take an x squared out. We can factor an x squared out. Then we're left with, yeah, x plus 5. And then once we get an x plus 5 right here, we want to work our tail off to get an x plus 5 here. So I would say just write that in there right away. Our goal is to get these two to be exactly the same. Okay? So now, what can I multiply times x plus 5, Daniel? Because this one is positive right here, yeah, it's going to have to be positive because I have to say x squared times x is x to the third, and x squared times 5 is 5x squared. So it has to be. Now, out here, that's a great question, Daniel. Out here, these two, remember, have to be the same, x plus 5 and x plus 5. I'm going to force them to be the same. Okay? So, what do I multiply by x plus 5 to get negative 20? 4. Okay? It has to be negative, and fortunately it is negative. Okay? But here's the question, and I know what Daniel's getting at. If I go negative 4 times 5, I get negative 20. And if I go negative 4 times x, I should get negative 4x. But this works out because remember right here, this is going to distribute. Okay, and it does distribute. So it's okay. That's a great question, Daniel. All right, so then what do we have left here? Think about it like this. Think about this as being inside another subdivision, okay? What can I factor outside of the green that's common? I guess I should go like this, not with the 0. What can I factor out, Rusty? Yeah, I can factor the x plus 5 out. X plus 5 comes out. And what am I left with? X squared times 1 minus 4 times 1. Okay, think about it like that. I think it makes it a little bit easier because, boy, this messes with some people's heads. So now I have x plus 5. That's not an x plus 5. Now I have x plus 5 times what? X squared minus 4. Okay, and that's exactly the same as this cubic up here because there's a squared and there's a x to the first. And don't forget r equals 0. So now what can I say? Kevin? Yeah, or 1 equals 0. So I can have x plus 5 equals 0 or x squared minus 4 equals 0. And that means x equals negative 5. Or this one I can work with a little bit because it's minus. This is magic, remember? What does x squared minus 4 equal? Uh, it means it's a special perfect square trinomial. Remember? X minus 2, x plus 2. You know, if you see x squared minus 4, x squared minus 9, x squared minus 16, x squared minus 25, etc., those are all perfect square trinomials. And when you see that, it's just money. Okay? So then you do it again, x squared, x equals negative 5, or x plus 2 equals 0, or x minus 2 equals 0. And from there, you all can solve it. And that's wicked cool. That's another way. Because remember, if you have a third degree polynomial, what are the possible number of real roots? 1, not 0, 1, 2, or 3 real roots. Okay? In this case, we got 2, negative 2, and negative 5. If you have a fourth degree polynomial, or fifth degree, whatever. No, I should go 4. I should go 4. That's better. Fourth degree polynomial, like the one we started with, the fundamental theorem of algebra tells us what? 0, 1, 2, 3, or 4 real roots. You might have 0 on that because it's an even numbered exponent. You know, that W or that M-shaped graph can be above the x-axis or totally below the x-axis. Whereas this third degree one has to have at least one real root because it does that. Okay? Any last minute questions? All right, I'm going to stop this time. I think I forgot to hit stop last time. Have a great day.